Hey everyone, welcome back to Pine Hollow Auto Diagnostics. Yesterday, I was actually out of town for one day. I went up to upstate New York to visit some family. I stopped by Eric O's South Main Auto Repair, had a good time there. And then while I was away, I get a call from my wife. And on the phone she sounded very distraught. She says, "Ivan, I have a problem." I'm like, "That's what I do. I solve problems. What's your problem?" She says, "My car, it just completely lost power. I was cruising, RPMs went up, she coasted to the side of the road, put on her flashers, could not go anywhere. No reverse, no drive. The engine still runs." So I told her, as long as you're safe, make sure your car's off the road, call AAA, get it towed here. So this is where we are. Right now, the 2010 Nissan Rogue is a beached whale. Didn't see this coming. So let's see here. Start it up. And I swear, anytime I leave, even for a day, something breaks here. I don't know how that happens, but anyways, now we have to fix this thing. And she still had to get to work today, so I'm like, take one of my cars. But girls, some of them don't really like to drive manual transmissions, so that's a stick shift, that's a stick shift, that's a stick shift. The only car we had available that was an automatic was my old 1989 Mazda MPV, which, as luck would have it, lost second gear last weekend on a trip to a bike race at like 243,000 miles. The second gear just started slipping and it went out. So now we have to rev it in first gear and then let off the gas, and it'll eventually go into third. So I kind of felt bad, making it drive that, but it drives it better than this thing at the moment. So here's the symptoms. Nothing. Like, every gear is basically neutral. And when this happened, she said there was no bad sounds, it just kind of revved up and that was it. So cross my fingers. I hope it's not a catastrophic transmission failure. Obviously it's transmission related, but it's not like the CVT, big chain, belt, whatever, snapped and caused and destroyed everything. Here we have to start with just trouble codes. So in the engine menu, let's just read the trouble codes, and check engine light didn't come on or anything. Okay, so we do have some direction here. ASCD speed sensor signal diff, VSS signal circuit failure, input secondary pulley speed mismatch. Guess that makes sense. So remember those codes, and let's go to the transmission menu. Let's see, codes only. We have two codes in the transmission. 720, vehicle speed sensor circuit secondary speed sensor, okay, and a 746, pressure control solenoid valve A performance line pressure. So considering the car right now has absolutely no gears, like you can't move under its own power, this line pressure problem, I'm guessing, is what's causing the speed sensor issues, because you put in gear, you rev it up, the computer predicts that you're going to have an output speed, but you don't, and if it doesn't see a signal from the output speed sensor, then it could set a circuit code. So it doesn't necessarily mean our speed sensor went out and our whatever line pressure solenoid went out, but that's what we have to work with. We can go to the troubleshooter and just look up a 720 and a 746 just for a quick reference here. CP0720, that's the, so let's see. So this code sets when the TCM does not receive proper signal from the CVT vehicle speed sensor secondary speed sensor. Okay. It detects the rotation of the CVT output shaft and emits a pulse signal which sent to the TCM. Okay. Right. So basically you drop it in gear, you press on the gas, and there's no output speed obviously, so that definitely could be why this code is setting. Now the 746, sorry about the glare, it's a nice sunny day. Let's see here. Detects gear ratio is too low due to low line pressure. Code is set by mechanical line pressure solenoid failure, not electrical failure. TCM monitors gear ratio using speed input sensor, primary speed sensor, vehicle speed sensor. Okay. Line pressure using primary pressure sensor. So we should have a data PID for this primary pressure sensor. Okay. And interesting. So let's just pop into the data stream in our transmission. See what we have available. I think we'll just look at everything, 1 and 2. So let's see here. Speed sensors, primary speed sensor, that's the, if you rev it up, that should go up. Primary hydraulic sensor, 0.00 volts. I don't like that. And, I mean, what else do we have here? Line pressure solenoid valve monitor. I'm not familiar with all these abbreviations from Nissan, but that jumps out at me. How can we have no pressure at all in any gear? It just stays at 0. The sound changed a little bit. So basically we have to go online, our information database, and do research because it's an unfamiliar system and we just need more information than we have here because again we need to know what to look at and yeah, make a diagnosis from there. So let's jump on the laptop and see what we can find. So while we're here on the scanner, I found this data PID. It's called SolMon2, line pressure solenoid valve monitor. So right now in park it's reading 0.6, and I don't know what the actual numbers mean. It might be a duty cycle from like 0 to 1. Let's drop it in reverse. Okay, so I can actually hear a change in the sound, and our value dropped down. I put it in neutral, put it in drive. Okay, there's the sound, and again we dropped to the same 0.4. Let me rev it up. Let me slowly rev it up. Very interesting. So let's do a custom display here of the engine RPM, primary RPM, and this line pressure solenoid. Again, apologize for the glare. I can't really move this car anywhere. I mean, I could push it with my SUV, but right now this is where we're doing our diagnosis, wherever the tow truck guy dropped it off. So let's view that. So primary speed sensor and this valve monitor. Let's put it in park. This is in park. So engine speed and primary speed sensor are not the same thing, apparently. Okay. Trying to zoom you guys in and also be able to see myself. So how about we can review this data later. Jeez. There. This is revving it up in park. Okay, now let's put in whatever, drive. So you can see the primary speed is now following the engine speed signal, right? Now, is that following it directly? I think it is. Okay, that's cool. So we know that the shifter did do something. Now the primary shaft is engaged, and since the computer sees a primary speed signal and does not see a secondary output speed, that's setting our speed sensor fault codes, okay? That makes sense. And our line pressure solenoid valve is definitely responding. So it's not a electrical solenoid failure, or even, I guess it could be a mechanical solenoid failure if that line pressure solenoid got stuck in, position mechanically. Let's put it back in park. You can see the input speed drops. Yep, input speed drops to like 30 RPM. Put it back in drive. Very cool. So my question is, right now, for this line pressure solenoid, is it mechanically moving? Is there line pressure in this transmission? I think in the troubleshooter there was a test to measure line pressure. Let's see here. Let's exit out of here. Back. Troubleshooter. Go back to our 0746 code. Okay, it says right here, TCM monitors line pressure using primary pressure sensor, right there, and you can back probe pin 41 at TCM connector. With vehicle idling in neutral, operating temp signal from primary pressure sensor should be 0.7 to 1.2 volts. Interesting. If not okay, perform the pressure test. So let's do this and see if our pressure sensor is reporting any pressure at all. And if it's not okay, perform an actual mechanical line pressure test. Verify the fluid is full, linkage is good, apply the brakes, and even give you a reference to see where this line pressure test port location is. They want you to connect a 5,000 psi pressure transducer to this port, and then it says the pressure should be about 109 psi idle and about 800 psi to wide open throttle. Flange pressure is not okay. Suspect internal CVT failure. Okay. Flange pressure is okay. Check primary and secondary speed sensors. So this line pressure, I think, will be the answer to everything. And we didn't really, it was showing 0.0 on the primary pressure sensor. I think that's a problem. We might not have any pressure at all since the car is, completely dead. It might explain everything. Now, why? Then the question is, why don't we have line pressure? Is it a solenoid fault? Is it a pump fault? Again, I'm not a transmission specialist by any means, and these CVT transmissions, I don't know much about them at all. So let's go do some research, but we do have a good direction here just using the scanner. Alright, the research station. So first thing I like to do is, for any system, is just to print out a wiring diagram. This is from BBB Industries. CVT control system. Here's our transmission control module. It is a separate unit. And then here is the CVT transmission assembly. So what we're focused on here is this line pressure solenoid valve. So we have 4 solenoids in here, it looks like. There's a primary pressure sensor, secondary pressure sensor. This was the one that was showing 0.00 volts. So I do want to verify the actual voltage signal coming into the TCM, and we want to analyze this line pressure solenoid valve. See if there's any current going to it. We can actually measure the resistance. So if we look up the the flow chart for this 746 code, let's see here. So there's our detection logic. It says unexpected gear ratio was detected in the low side due to excessively low line pressure. So the line pressure control system, secondary speed sensor, or primary speed sensor. Possible causes. And like I said, I'm not worried about these speed sensors. We're worried about the actual line pressure. So it tells you how to check it. Drive it at 6 miles per hour, which we can't do. Check line pressure solenoid valve. It says turn ignition switch off, disconnect CVT unit connector. Check line pressure solenoid valve. Is the inspection result normal? And the check for that is simply a resistance check. F24 terminal 2, it should be 3 to 9 ohms. So we could definitely start there. Even though electrically I'm sure this is going to check out just fine. So they're saying unplug it here. There's terminal 2, and the wire color that we're looking for, these are the pinouts. So you can see the actual connector number right there, F25. That's at the TCM, but at the CVT it's F24. So we go to this page, and let's see here, F24 CVT unit, and it looks like that. And if we use a highlighter here, there's our terminal 2. It's a yellow wire. Line pressure solenoid valve. And we're also interested in the primary pressure sensor, which is pin 25. It's a brown wire. Okay, so now let's go to the vehicle, find this connector, locate the wires, and do the electrical checks that they recommend here. So I propped the vehicle up safely on a jack stand. Parking brake is engaged, the wheel liner is off, and right here we have good access to this CVT bulk connector. And according to our diagram, let's see here, that's what it looks like right there. So if we have a brown wire in the top right corner, that will be our primary pressure sensor. And sure enough, there it is. That's the brown wire right there. So that's our orientation. And we're also interested in pin 2, which is yellow line pressure solenoid valve. And that's this guy right here. That's the yellow wire. So cool, easy to access. And if we can back probe this, I really don't want to poke holes in here because it's right by the wheel, and the green crusties won't take long if we don't seal that up well enough. So again, they say unplug this guy, and not exactly sure how to disengage. Oh, okay, so it twists. Okay, so you keep twisting off and it kind of backs itself off. Okay, there we go. So that pin right there, pin 25, we can measure the resistance from there to ground and just verify that that line pressure solenoid is, 3 to 9 ohms like the flowchart said. So here's where the AES Wave adapter kit comes in handy once again. Those pins are really fine, so I'd rather pick the correct adapter, and so we don't damage these pins. So like this one, that's still too big. I'm going to try one of these really fine. It's kind of a round end, and that should work. Still a little loose. I don't know if they get any smaller. Okay, so this yellow guy actually fits on the pin really nicely. Let's get our meter out and do the resistance check. Alright, the proof is in the pudding. We have about 7 ohms. That's on pin 2, which is right here, the line pressure solenoid valve. So again, electrically it is fine. But is it moving mechanically? That is my next question. What we can do is just supply direct power to that pin, briefly, and then monitor the current going through the solenoid. And it's actually really neat if you haven't seen a solenoid current ramp. You can actually see the solenoid open. It's almost like when you see the pintle hump on the fuel injector. It's similar, but it's even more pronounced. So let's do that bypass test with a current clamp and a scope, and just verify that that solenoid is moving mechanically. That's my next step. All right, here's the experimental setup. We have our CVT connector disconnected. We are on that pin 2 going to the line pressure solenoid. Right here is a blue lead. That's channel 1 on our picoscope. And then channel 2 is an amp clamp. And this red wire is connected to battery positive through a fuse. And on the end here, I just have a needle probe. So the experiment's going to be, let the scope run and touch the needle probe to the back side of this connector. And that should send current to our line pressure solenoid, and we should see on our scope, the input voltage and also the current going through the solenoid. And hopefully that will give us enough evidence to see if the solenoid is mechanically moving. And we should also be able to hear the click. So let's give it a shot. So you see some sparks fly, right? You hear it? Let's see what we saw on the scope. Let's see, pause that. Okay, it's not a very clean contact when I touch the pin on there. But you can see that, and you heard it move, and see the current ramps up slowly, so the coil winding is good. It's not shorted out or anything. And the voltage here, that should be battery voltage right there. And when the solenoid turns off, that's when you see these voltage spikes. And if you look close, We can even drop the voltage scale down a little bit. There is almost like a pintle hump on a fuel injector. So that's the solenoid mechanically closing. So there's nothing wrong with the solenoid. A new valve body is it's not going to fix this. And I'll save you guys some time. I looked online through Nissan. For this transmission, it's basically sold as a unit. You can't buy solenoids, you can't buy a valve body, you can't buy any replacement parts, just the whole assembly. And well, I'll show you the price here. We already have it pulled up. Well, I guess we can look it up on all data. Let's see, vehicle. We want to see transmission and drivetrain, continuously variable transmission, transaxle, and replace. Complete assembly without transfer of parts, 8.6 hours. And no, it doesn't give me a price. Let me look up a price for this thing. Well, here it is. OEM Nissan parts, transaxle, all-wheel drive, California emissions without premium package. MSRP is $2,600. That's it. I looked online for like salvage transmissions. They're almost the same price. They're like $2,000 because apparently these things are in pretty high demand. So I don't know. Might have to bite the bullet on this one and get a new transmission, because otherwise it's still cheaper than a new vehicle. I mean, this thing is pretty much mint. Let's see how much. Well, I don't want to turn it on with a connector unplugged, but it has 186,000 miles on it. Pretty, you know, easy highway miles, no towing. So yeah, Nissan. A little disappointed right now because this has been, up till now, the most reliable vehicle I have ever, you know, serviced or maintained. But something like this, it's just, you know, kind of a shame. You just have to buy the whole unit, and you have to pay out of pocket because even the extended warranty only covers 120,000 miles. So, yeah, it is what it is. But, you know, hopefully you enjoy the diagnosis. I guess, yeah, I don't know if I'll videotape installing this transmission. That probably won't be very fun. But, yeah, thanks a lot for watching. I'll see you next time. Bye-bye. Alright, a little bonus footage while we still have the scope out. 2 channels. One is on the line pressure solenoid, and the other one is on that primary pressure sensor. This guy right here. Oh, sorry. Primary pressure sensor. So that's pin 25 on the CVT. So what I want to do is start the car up, you know, put it in gear, see, look at scan data and the scope, and see if that command is there from the TCM to the line pressure solenoid, and then see what the response is on that pressure sensor. Now, I assume we won't have any response since the scan data showed 0, but you never know. You might as well look at the raw data and see what goes on. So let's get the scope inside the vehicle and run it through the gears. Alright, we have the scope rolling. Let's turn the key on. Okay, so we already have a duty cycle signal, it looks like, from the TCM. Let's start it up. So frame 3 is going to be put in reverse, neutral, drive, low, back in park, shut the key off. Alright, let's zoom in on this. Whoa. Oh boy. So there's our duty cycle. okay. Let's back up a couple frames. See, it does change. So the command is there from the TCM. See that, you know, it changes, and the pressure sensor reports basically nothing. It's definitely stuck at 0, so we have no line pressure, no pressure in our CVT, even though the command is there, and we know that solenoid is, at least it's clicking, so it's either a pump issue, but again, I don't really know the internals of these things. Last check we could just look at the fluid level, but you know, it's fine. It's still the original fluid, and it still looks clean. Let's go under the hood here. And this thing actually has like a fuel or a fluid life monitor. Let's see here. Let's get this funky dipstick. Let's see if we can get it out single-handedly here. You have to press the little tab and stuff. Alright, let me get that out just a sec. Alright, so you pop this guy out, and the fluid is, you know, it's there. It's definitely full. It's not black or anything. But the life monitor says it still has another like 100,000 miles to go in this fluid. Whatever. Needs a tranny. See you guys next time. Bye-bye.